Okay guys, I will solve with you now. You can solve that also. Projectile motion for a body projected from point 1 to point 3, passing through point 2, which is the highest altitude. The initial velocity v1 is equal to 50 meters per second, and the angle of the angle is 30 degree. It is not 30 here, but it is in the calculations should be 30. Okay. In this case, we have motion in two directions. We have velocity in x direction, vx, and velocity also in x direction. And we don't have any air resistance here, so the the track is parabola. There is no changing. If we have any air resistant and friction force, the track will be in this case, in this shape. Then the maximum x displacement, and which is the range, will be reduced, but we will not solve for any friction force in this example or any other example. Okay, we have also velocity in y direction, positive y direction at point 1, and the velocity at the highest point vy at point 2 is equal to 0, and vy here is in negative y direction. We need to know also we don't have any acceleration in x direction, so a in x direction is equal to 0 always, and the acceleration in y direction is always g, which is minus 9.8 meters per square second, which is due to gravity. And because of that, the body, when it's climbing to the highest point, its velocity in y direction reduced, then it is increased again. So we need now to use the equations of motion in both directions, x and y. For x, we don't have any acceleration. We have x is equal to v multiplied by t. Vx, we have the vector of the velocity v naught, which is equal to 50, and we have the angle 30 degrees. We have now two components. The first one is Vx and the second one is Vy. Vx will be constant always. Vx is equal to V naught cosine 30. Cosine 30 is root of 3 over 2, and V naught is 50. This is Vx. It will be constant. But Vy at point 1 is equal to V naught sine 30, which is 50, the V naught, and sine 30 is half, and Vy at point 1 is equal to 25 meters per second. It will change. Okay, so x at any point is equal to the initial velocity multiplied by cosine, and we compute it here, multiplied by t. This is x of t as a function of t. As we said, v of x is equal to v1 multiplied by cosine theta, which is, it will be 50 cosine 30 is equal to Vx always equal to 43.3 meters per second. Okay, the equations for y direction, we have y at any time t, so this is a function of t, is equal to y naught, that is depend where are we start, and to find the place and position of the body, we will see now. Vy at time t plus half the acceleration in y direction is g. This equation is x equal to x naught plus v naught multiplied by t plus half a t squared. This is in x direction, but we have now in y direction. We don't have any acceleration in x direction, so this value will be 0. X naught here is also 0. We suppose that we are at origin here. So we have x is equal to v multiplied by t as we see here. Okay. And we have the second equation is v2. This is for y is equal to v1. I'm talking here about y velocities plus g multiplied by t, and vy2 or is equal to vy1 squared plus 2gy. They are the same equations of motion. Okay, now I need to find t, the time from point 1 to point 2. This is point 1 and this is point 2. This is the time of climbing, and I need you to find t from 2 to 3. This is 2 and this is the 3. The falling time, this is time of falling, going down. And also I need the time of flying time, which is the time of climbing and the time of falling. Okay, and I need also to find the maximum altitude. The maximum altitude at point 2. I told you that Vy at that point is 0 because the body is going up and then going down. At this point, at the maximum point, the y velocity is 0, but x velocity is constant. You see that how the pin is moving, its x motion is constant, but y motion, look, at this point, maximum point, the velocity for y is 0 and it will fall down again. Okay, then I need to find the maximum x displacement. I need you to compute the range from point 1 to point 3. Also I need you to find the velocity at for y component, the y component of the velocity at final point. I need the velocity Vy here, Vy3, and I need also Vx3. We told that Vx will be constant all the way. And I need the final speed. The speed is the magnitude of the velocity, which is composed of Vx and Vy. And I need the angle, the direction. I need this angle. I know that the first angle here is 30. You will find, and we will find now, that this angle is also 30. It will be negative because it is down the x-axis. And the velocity, the initial velocity is 50 here. We will find that also this velocity is 50 because we don't have any friction force. We don't have any air resistance force. But if we have, this will be changed. Okay, I will move to the next, to the first required quantity, which is the time from point 1 to point 2. I will use any one of these equations that make me solve what I need to solve. I'm solving in y direction now. I will use the second equation here. Okay, Vy2 is equal to Vy1. This is Vy1 here, Vy1. This is Vy2 is equal to 0. Okay, plus G multiplied by T. T is the time to climb to this point. Okay, V2 is equal to 0. Vy1 is V1 multiplied by sine theta, which is 30, plus negative 9.8. This is the acceleration due to gravity. Negative sign because it is downward. Multiplied by T. This T is climbing T. T to going up. Okay. I can move this quantity to the opposite side. It will be positive 9.8 T is equal to 50 multiplied by sine 30, which is 25. I will divide both sides over 9.8. Then T going up from 1 to 2 is equal to 2.55 seconds climbing time. Okay, now I need the time from 2 to 3, that going down time. Here at first point, I know we can find the V at this point and V at this point, but if we come to this case, we don't know the velocity here. Later we will find it is equal to this one, but now we don't know how much the velocity here. We can't use this equation. We will use another equation. Don't have the velocity V3. Okay, so this contain V at initial and final point. I can't use